This is part 3 of the Earth's atmosphere topic. It's a GCSE AQA chemistry dual award topic, which means dual and triple award students will need to be familiar with the content. Going to recommend you pause as you go and have a go at the activities. In this video, we're going to take a look at the greenhouse effect, the problems it causes and why it exists. So we need to know how the greenhouse effect operates, evaluate quality of evidence, so we're going to do some graphical analysis, look at uncertainties in evidence, and understand the importance of peer reviewing of results. Let's start by taking a look at these questions. So there's a diagram here to help you. The sun heats up the earth. We know that some escapes directly into space. We know that we've got CO2, H2O, CH4 trapped in the atmosphere. The diagram itself does not tell us the full picture. And there are some specifics here that you need to remember. So it's going to be written quite small, and I will take my time talking it through. Short wavelength radiation is absorbed by the Earth. So it comes in from the sun and it's absorbed by the Earth itself. That's an important first point. When that energy is emitted back out, it's a longer wavelength radiation. So short length radiation is absorbed, longer wavelength radiation is emitted. But the longer wavelength radiation is absorbed by the greenhouse gases, by the carbon dioxide, by the methane, by the water vapour. And that means it doesn't escape out of the atmosphere, it's trapped in the atmosphere. The impact of that is that global temperatures rise, but there's actually much, much more than that. And there's a whole video coming up within this series where we talk about that in more detail. Now, without any carbon dioxide in the atmosphere, the average global temperature would be negative 19 degrees C. Why would that be a problem? The issue is, if we take a look just at water that sustains life would be frozen. It would be difficult to sustain life at that temperature. We'd need to use a lot more energy to raise temperatures to make places habitable. Okay, take a look at this, have a go at analysing this graph. And it's really important that we look at the detail of this graph. It is a curve. So you could say, in the first instance, over time, carbon dioxide concentration is increasing. It certainly is. But that would be true for a straight line going up as well. So we also need to highlight the fact that the gradient is increasing. There's different ways of saying that. I've said that the rate at which carbon dioxide percentage is increasing is increasing. There's an increase in the rate of increase. Okay, we're going to move on. We're going to take a look at something which is hopefully familiar from earlier topics. Have a go at these. So it's a practice of combustion of hydrocarbons. We need to know that prop is 3 and bute is 4, and we need to know the general formula of alkanes to get to C3H8 and C4H10. When we combust, we react with oxygen. We need to remember that oxygen is a diatomic molecule. And we need to know the product of combustion are CO2, because it's complete combustion, and H2O, which is always a product of combustion of a hydrocarbon. I then go through and I balance. I'm going to follow the rule of Cho, balance the carbon, then the hydrogen, then the oxygen. I will always do that in combustion of hydrocarbon equations. 3 CO2 and 4 CO2. Now, I'm then going to balance my hydrogens. I've got 8 on the left here, so that's 4H2O, 10 on the left here, so that's 5H2O. And then I'm going to count up my oxygens on the right. I've got 3 times 2, 6, plus another 4, that's 10. So I need 5 O2 to balance that. And I've got 4 times 2, 8, plus another 5 is 13. I need 6.5 O2 to balance that. There are various sources of methane. Now, we talk about carbon dioxide as a greenhouse gas. Methane is also. What are the key sources of methane that pump methane into the atmosphere, contributing to global warming? Swamps and rice fields, that's one. You get huge amounts of methane from them. You also get it from decomposing waste. Now, as human population has grown, there's a lot more waste now. We put a lot of waste into landfill, so landfill becomes a source for methane. And also, we eat a lot of meat. And that meat, cattle in particular, when it emit gases, it emits methane. So we've got lots of ways of thinking about that there. Going to move on to some analysis type questions here now. The majority of scientists do agree that human activity is having an impact on global temperatures and contributing to global warming. There are a small minority that say, no, it's entirely natural, nothing to do with anything we're doing. Let's have a look at a range of pieces of evidence and see what we think from there. Have a think about this one. Now, if this was the only piece of information that you were given, there are a couple of things that stand out. One, I would note that this has been higher in the past. Just about 150,000 years ago, carbon dioxide concentrations were higher. About 430,000 years ago, they were higher. I also look at the fact that there are regular patterns. It goes from a peak and it then drops, peak and drops, peak and drops. And we look like we're at the beginning of that peak there. So on the basis of just this evidence, it does support the idea that the carbon dioxide concentration cycles up and down regularly. It's nothing to do with us. It's nothing to do with anything we are doing. Let's take a look at another piece of evidence. See what you can do with this. So we've got here the natural factors that affect carbon dioxide concentration. And we can see it goes up and down, but it isn't massively changing over time. Certainly over the last, this is over 125 years. And actually, I've put the red line here to show the average. And even though the natural factors aren't changing, carbon dioxide is going up. That tells us there is something beyond natural factors that's having an impact. Potential human impact on carbon dioxide concentrations going up. Final piece of evidence to take a look at. And I think there's some very clear correlation here. As the CO2 concentration goes up, there is a direct link to the carbon dioxide concentration, the general pattern of carbon dioxide concentration. So we are seeing a link between CO2 concentration and global temperature. We know, and we saw on the previous graph, that carbon dioxide concentration is going up, not due to natural factors. So it makes sense that it's gone up due to our increased use of burning fossil fuels. So you piece all of that information together and it becomes quite compelling that we are quite significantly responsible for the changes that are happening. Going to finish off by taking a look at this question. Because obviously we know what's happened before. Why might it be difficult to predict what will happen in the future? In the simplest terms, we can't know what future circumstances will be. Let's take a look at some examples of that. There might be technological advancements that mean we can totally abandon fossil fuels, at which point there might be a significant decrease in carbon dioxide, or certainly a stop in the increase in carbon dioxide. There might be efforts to decrease fossil fuel use. Certainly, there are countries around the world that are doing that. But it's also possible that there might be an acceleration in fossil fuel use in other places around the globe. And the final point to look at here is populations might change. Population might decrease significantly, which would have a major impact, but population could continue to increase significantly. All of these things could happen. We don't know which will happen. So for that reason, it is very difficult to actually predict what's going to happen in the future with any level of certainty. That takes us to the end of this video. Thank you for listening and goodbye.